and everything is on the clock. 100,000 words consumed a day, 443 minutes of video cross our screens every 24 hours. The equivalent of watching 4 Star Wars films a day. And we're still hungry for more.
Why do you slip on ice? Why do we see faces and objects?
How do dung beetles read the stars?
So many questions, so much science, so little time. Want answers to your universe as fast as possible? Start the clock for The Quick and the Curious. What do the Man on Mars, the Cross-Eyed Telescope, and the Happy Cappuccino have in common? They're all looking right at you. Or at least you instantly think that they are. So, why are we so quick to see faces in objects? It's a strange phenomenon that's evolved over the past few million years. Pareidolia. And it happens to everyone. And once you see Jesus in a frying pan, or Jesus on a shoe, or Jesus in a chicken wing, it's virtually impossible to unsee it. The part of the brain that recognizes faces is called the fusiform gyrus. It can spot a face in just 130 milliseconds. But anything with a face-like arrangement can trigger it too, which can lead to some mistakes. But why does the brain do that? It's an evolutionary survival tactic. If a jogger in the woods happens to see something that looks like the face of a bear, she can run away. But if the jogger didn't see a bear and there was one, she's breakfast. So, why are we so quick to see faces in objects? It's an adaptation that helped our ancestors survive predators. But today, it helps people fatten their wallets. This George Washington chicken nugget was auctioned for $8,100, thanks to evolution.
In the insect world, dung beetles don't get much respect. It's sort of inevitable when your calling card is rolling around animal droppings for a living. But reputations can be deceiving. These pint-sized poop pushers actually share some amazing abilities with the great voyagers who used astronomy to navigate the globe. So how do dung beetles read the stars?
To farmers and ranchers, dung beetles are heroes because they keep soil enriched and move cattle droppings underground and away from the livestock. To feed their babies, dung beetles must push their pungent prize in a straight line, stretching up to 100 yards from where they started. But they sure don't have GPS. So how do they know how to get to where they're going? The stars. How did scientists learn this? Researchers began by tracking the movements of a control group of beetles that wandered around normally. The researchers affixed another group of dung beetles with little dung beetle hats. Yes, there are people who do this for a living. The hats covered the beetle's dorsal eyes, which are located on top of its head, while leaving their ventral eyes, which point toward the ground, uncovered. Even though the hat-wearing dung beetles could still see the ground, they wandered around in circles, completely lost. They needed to see the sky to get from dung to dung. To double-check their theory that dung beetles were using the stars to navigate, scientists took a bunch of beetles on a field trip to a planetarium. Once inside the planetarium, the scientists learned something even more amazing. It's not the bright light of the stars and moon that the dung beetles navigate relative to. It's actually the far dimmer glow of the Milky Way. Because whenever the Milky Way was covered up, the beetles were completely lost. So, what do dung beetles have in common with the great explorers? They navigate the stars and have the stomach to go where no one else wants to.
When people experience a traumatic accident, like a car crash, they often report that time slows down. In one experiment, people falling 150 feet into a safety net reported that the drop took 1/3 longer than it actually did. But this time warp is just a memory trick. Your amygdala, the fear center of your brain, lays down an extra set of memories in addition to what your brain normally records. Now, this denser set of remembrances makes the event feel longer than it actually was. Our experiences can warp our sense of time, but can time actually move at different speeds?
Yes, it can. Time moves more quickly up top than down below. But how? How does your head age faster than your feet? It's an effect called gravitational time dilation. Gravity stretches time. The more gravity there is pulling on you, the slower time goes. A person in a jumbo jet at 30,000 feet is feeling less of a gravitational pull than a person on the ground, so time moves faster up in the friendly skies. Similarly, because your feet are closer to the ground, gravity pulls more strongly on them than on your head, so time moves faster around your head than around your toes. How much faster? Over the course of a 79-year lifespan, your head becomes a whopping 90 billionths of a second older than your toes. But how do we even know that? Scientists never had an instrument precise enough to measure the effect over such a short distance. Until now. This is the strontium atomic clock. It measures time through the trillions of tiny oscillations of the strontium atom. This incredible precision allows it to measure the effects of gravitational time dilation, even over the distance of just 1 foot. So, how does your head age faster than your feet? Because it's further away from the ground. Just a little motivation to get your head out of the clouds.